colleagues here, one colleague said about hydrogen in blast furnace. We don't have much experience. Looks like that we cannot have any use, but still I will show on the particularly biomass application, charcoal application in blast furnace. Some of the work we did, I will try to show you that from the paper.
Charcoal to replace coal.
Yeah. So that sort of scenario. Second one is that carbon capture and storage. I think one colleague wanted to know. I will show you probably that's one of basically those papers I will go through rather than slides, because I don't have the slides on that. And then the third one, I think someone said another item. I forgot that one. That gentleman wanted to see something. I forgot. So I will show you probably that. That's the. What was that gentleman asked?
Sinter plant.
Using sinter plant. SAR using sinter plant. That's also I've got some work. And these works actually nobody in the world have done. We did quite a long time. We had a lot of work project on that. So at least some results are there, publicly available. One of my colleagues, Roy Lovell, he published paper, and I know about that work, so I can probably share experience on that. So, but also we need to continue the hydrogen discussion, and so we just initially similar sort of information I'm going to give, but this time I'm going to give a little bit international activities, what is happening in developing countries, developed countries, and also for the solid oxide electrolyzer I will focus a bit more. So as I said, PEM, solid oxide electrolyzer, these are the two areas we are kind of working closely with a lot of experiences. And I'll also mention that how one of the key piece of information about all these technologies, as I said, the material challenge. What are the materials? If you talk about gigawatt scale. So what are the solutions? One solution we already, I am the lead, one project we have started on 1st of July, the recycling of hydrogen. What's the future? So I showed you those sort of special materials, particularly solid oxide electrolyzer, which use rare earths, which use yttria, zirconia. How can we recover zirconia? And you can recover it. It's not a big deal because hydrometallurgy, pyrometallurgy, or mixed kind of technology, you can recover it. But ultimately, the specification of the product you recover has to meet that it can go back to the recycling production system, and you can produce new material, new solid oxide electrolyzer, new PEM electrolyzer. So once end of life, because we have a lot of end of life cells, we know because it's finished, it died. So what we're going to do is smash it and then do lots of tests, experiments, and try to recover material and see whether that material meet the specification of the product so that we can make a new product. So that will solve to some extent, and I think somehow I got convinced and I convinced the people who are funding that yeah, this is the way we need to think about. And although some people are good, oh, the technology is not mature yet. Who knows when hydrogen technology will be? So why are you thinking about recycling? I sort of was adamant and I said, this is the first thing you need to do. You develop a technology. If you don't have the recycling strategy now, then we know the materials will be a challenge, materials available in supply, requirements. So we should focus on recycling now. And that's a good thing that I think I'm going to maybe in a couple of years, we will have some results how you can recycle materials from hydrogen technologies and make new equipment so that can potentially reduce the cost and also solve that material issue, and at the same time it becomes circular. Because once you make a product and later you think how to recycle, already like I think yesterday in ISM Bangalore, one of the students asked us what is happening in solar panel recycling. So you have lots of solar panels and it's very difficult to recycle, to be honest. There is silica, and it's not a very high value product there. You can take just some steel and other structure out and what is left, not much. A little bit. So that's in that case that all the solar panel industry now thinking, well, we have designed the product in a way that we can recycle. So in hydrogen technology, at least the technology we are working on, whether it's PEM or solid oxide electrolyzer, we should have recycling, and we have done quite a bit of review. What are the technologies possibly available? Only one team in Europe, they call H4Y or something like that. So they are the only group. A couple of years ago, they have started recycling of electrolyzer, and particularly not electrolyzer, they are recycling of fuel cells because there is a lot of fuel cell around now. It's very, very early stage of research. I don't know anyone else, maybe Japanese, maybe Korean, usually they're very good at recycling, they may have started, but I think that needs to be looked at. So that's I need to note past that this is another area. You will see that we will be looking at research on hydrogen technology recycling. So I think let's move on. So again, we have talked about hydrogen as a clean alternative to natural gas. Potentially, it is the most abundant chemical element, accounting for nearly 75% of the universe's mass. Water, plants, animals, humans on Earth contain vast numbers of hydrogen atoms. So that's why we are attacking. Despite its presence in almost all molecules in living things, hydrogen is very scarce as a gas, less than 1 part per million by volume. So it's a low density gas. A variety of sources including natural gas, nuclear power, biogas, renewable power, solar and wind can be used to produce hydrogen. We have gone through that already. Significant challenges lie ahead in harnessing hydrogen as a gas on a large scale to fuel homes, businesses, industries, power plants, and so that's the significant challenge exists, and that's the opportunity. So that's why they remind ourselves, refreshing that, the same information, but the challenge. So now, what is happening? So natural gas, renewable sources, nuclear potentially can come in, coal, so you've got hydrogen energy, fuel cells, which that's one of the major use for transport. Transport sector will be prime user for hydrogen, engines, turbines, energy storage potentially, and in the chemicals, as I said, ethanol plant, they are desperate for clean hydrogen. Petroleum, already they are using petroleum industry. Electronics, ammonia production, lot of movement happening in the ammonia industry. They want clean hydrogen. And metal production, I think last time I was in TMS, I don't know whether you know about that. Food processing, cosmetics, and
So why we are the industry is not going for the hydrogen vehicles in spite of EV?
in spite of EVs.
Because right now the industry is going towards EV, the automotive industry. So why
not hydrogen?
Yeah, why not
That's the
hydrogen
question.
at this time?
At this time.
Because EV is just started 5 years back.
5 years are now taking over.
Now taking maybe next 15 years only EV will be there. So hydrogen will come after 15 years then.
Maybe, but my question to you, say EV small vehicles, okay. What about large vehicles? Say trucks, say buses, say trains. Do you run with EVs? Planes, you can say, ships.
We are not heard anything about.
No, buses
very heavy.
Buses are there.
Buses are there in EV.
Buses are there.
Buses are there in EV.
Delhi is Indonesia.
Delhi,
Buses.
Tehran.
Is buses.
Intercity buses.
Allhabad buses, I saw that actually EV buses. But
Inter-
how long does it take to charge?
The range is the
Range, then charging time, then weight. I mean, how much battery? If you look at the weight to mass ratio, battery will be some time.
Then my question is why not?
Why
the industry is not taking time in the hydrogen?
I'll tell you that my view is that this EV technology somehow, it's like solar technology. When there is a certain cost reduced, suddenly people say, oh, this is like
Okay.
EV that is spark will happen. Hydrogen that is spark is not here. So that cost, if it is easy, and you see the challenges. I mean, we are last 3 days we are talking about challenges, isn't it? Your material, your large. So we are talking about gigawatt scale industry, power plants, and you are talking about. So largest hydrogen electrolyzer we are talking about, say 20 megawatt. So it's a drop in the ocean.
In spite of focus in decarbonization in steel and power industry, first it should start from the EVs and vehicles.
Electric
It's-
vehicles. So you electrify it.
It's easy to, I think, impact.
And that's why they are taking quickly. So when we started hydrogen and EV, as you said, it started in a similar time. Maybe hydrogen came a little later. EV already was there, but it was. So we were discussing. If you talk to me that time, I said I worked with batteries.
You were saying in Australia there are 20-30 cars of hydrogen.
Hydrogen. Whereas there are hundreds. There are last year 100,000 EV cars
Yes.
were sold.
So the ratio is very low, na?
The ratio is very still low. Yeah. So that's why some people say maybe hydrogen has no future. Potentially, that is the possibility. But my feeling is that that's the cost point. Once that cost point,
Cost barrier.
Battery is same thing. Battery was $1,000 per kilowatt hour. Now it is less than 100. Or maybe around 100. If it goes below 100, it will be quite cheap in a sense for this sort of applications. But my feeling is still EV will be small application, short distance, city distance, probably within city.
Within the city.
Two-wheelers or in Indian context, in our context, it is city vehicles we call it. Intercity vehicles, EV, still people are petrol vehicle, right? So, but on the other hand, petrol decarbonization need, and not only that, air quality, etc. That's why then I think the solution is hydrogen. That's one story. Second is that it's not now yet because that cost is still high. And not, even if you say, can I get, say, 50 megawatt electrolyzer?
The cost is get down because of the government's thought that EV is the solution. So why the government is not thinking in the as hydrogen is the solution for the vehicles?
I'll show you Indian thinking, what Indian government is thinking.
Not only India, I'm talking the worldwide.
Other
Because the other country also hydrogen impact in the vehicle is very less.
Yeah.
Because CNG is available.
But you
Like
see
small
that investment,
comparatively cost.
EV market is mostly taken by Chinese. You see that one?
Yes, it's very hard.
Cattle, you know, the
Yeah, 90%.
what is comparable ampere resistance technology or something like that. Cattle has got 20,000 R&D workers, R&D engineers working with $4 billion budget. Just now.
In China.
In China. They have got half a dozen companies like that. If you look at the hydrogen investment, it's mainly government. And it's also, hydrogen investment is significant. Every country in India is probably investing a lot also, isn't it? Every country is investing a lot because it's a new technology. And my feeling is that the production, mass quantity, you say you want to order 50 megawatt hydrogen electrolyzer. Do you know how long that will take? Who is going to do that? Who is going to produce a 50 megawatt electrolyzer? Not many capabilities exist.
The government should start.
In Australia, country like Australia,
Yes.
their renewable energies, they are done hydrogen as potential.
Yes, potential, but problem is that not many maker. Because Australia has no manufacturing.
Power cost is low.
Low. So we need someone make large scale for us and give it to us. So we have some companies, but they are small. They might be 100 kilowatt, maybe few hundred, maybe few tens of megawatt. But if you talk about gigawatt, we are talking about who is going to that mass very quickly. At number one at a cost also. That has to be cheaper.
It is a responsibility of the developed country first. Obviously,
Well,
it is a responsibility of the developed country first.
Because they are already-
then the country like
India will
like
follow.
India.
Maybe that's this presentation. I'll show you what the other countries are thinking and why sometimes it's advantage for developing countries to get into the market because it's a distributed. You know that like what's Wi-Fi or what is it? Mobile phones suddenly becomes everywhere, isn't it? Even in the villages, even the I heard the Vegas have got. Actually, I don't know whether the Vegas they have got 5 phones or 1, 2 phones. So you imagine even iPhones. I don't know about that, but maybe that is. But you see that any technology takes, sometimes developed country has got upper hand. I think in that sense, but it has to be cheap, obviously. And if you make it locally, some of the cost might go down. So it's a matter of obviously, as you said, government is working definitely, and I'll show you what Indian government is in terms of hydrogen mission in this presentation. So anyway, so that's, but one thing I can see, metal production and fabrication, or particularly hydrogen in metallurgy. That's a theme. 2 years ago, did you hear of the hydrogen metallurgy? Or 3 years ago, maybe. Now there are dedicated sessions, conferences on hydrogen in metallurgy. I went to TAS, DCR, Las Vegas was conference, Abash was there also. So that I organized that it is 4,000, 5,000 metallurgists, mostly metallurgists, and other material scientists, they come in that place. So there is, I never heard of that hydrogen metallurgy or anything like that. Now there is a dedicated session on hydrogen metallurgy. They're thinking about.
There are suppose
Maybe that's why. If you go to the skill sessions, there are at least 5 papers, or in the session 5 papers, at least 2, 3 papers will be talking about hydrogen application. It's still research, it's still hypothetical maybe, but the discussion is taking place. So that's, I guess that's promising, isn't it? My sense that is promising. It will take a long time maybe, but it's still.
My view was that because in an industry like steel, the change is a bit slow because once we invest a huge amount for a technology, we will not change very soon. Suppose today I am building a plant with the blast furnace technology. I am not going to replace it for next 40 years.
I understand that.
But for the vehicles, each 10 years the old vehicle is scrapped, new vehicle come. So it's a cycle time is reduced.
Yeah.
Less cycle time.
Yeah, I agree. Hydrogen discussion is still academic world, isn't it? Lots of academic and research world. Because they are getting money from government maybe. there are funding, everybody wants to get some funding, wants to work, and, but the amount of funding is good, I would say, and lots of things, when we started in hydrogen work in Australia, say 10-15 years ago, only maybe 2-3 groups, maybe us total, maybe I don't know, 20 researchers. Now at least 3,000 researchers I know working in hydrogen area in Australia. Every university has got a hydrogen unit, more or less now. That is the trend in the US, Japan, Korea, Europe. I'm not sure India, maybe do you know any IITs or very actively in the hydrogen area?
Maybe Arup sir can tell.
I think
We are not in academic touch.
so, but NCL, I think NCL Pune, they are the lead for, as far as I know, Dr. Ashish Lele, his name is Ashish Lele, CCCRI, but these are government labs.
Yes, CCR.
But so that's Jayanta Mukherjee, I think his name is, a Bengali scientist. Very good. I think he's got 2 kilowatt system. Yeah, so solid oxide electrolyzer. He's a ceramic. So CCCRI all about ceramics, so they are moving into that kind of area. So it is true that it is still academic world, and that's why I think industry needs to be involved and direct the academic people. That looks like it's still in the theory. How can we make it more easier or near future technology? But I'm convinced. I was not initially like you. I was questioning how come 55 kilowatt of electricity you are putting in to get 1 kilowatt. How do you forget about that? No one will do that one. And if you have that much electricity, why don't you use as electricity? Why do you convert and all these things? But because renewables go up and down and your grid cannot cope, that's the only way to store chemical energy. Once you convert to chemical, you can move around, it becomes flexible. And hydrogen is a very flexible chemical because it can be used in methanol plant, it can be used in fertilizer plant, and steel making, but I think the technology needs changes. So, but on the other hand, you have a DRI already, new companies making probably DRI, right? New plants coming in, and in that case, you blend with natural gas. That's not really my answer, but it's still, I think it's difficult for me, right? That immediate future. So that's another car. I think most of the car industry that came, somehow I got some association. So Catco is a gas company, and they took that one. That's zero emissions. Every hydrogen car in Australia they call zero emission vehicle. So it is just like emission zero. That's
It should be.
running is zero. So just water, obviously. And then you can see the structure. So that's the tank. So you see that there is a fuel cell. I think that's the fuel cell, isn't it? And that's 2 tanks. So 5 kilogram, 2 kilogram, total 7 kilogram tank. And that sends to the fuel cell. So you know, if you talk about EV, same thing. EV needs charging, and this doesn't need charging. So you go to the petrol station, you fuel. Hydrogen station will fill 3 minutes. The same thing, kind of. Whereas, so that flexibility, so you say from here to 700 kilometers you want to go, how many times is this charge? So there is that's why when people ask me, you are for hydrogen or you are for EV, I said both. You have to have mixed technologies. So one technology does not replace other. And particularly say, so that's number one, so that's the thing where they go through. So that's air is going through. 2 is hydrogen stored in tank. 3 is hydrogen oxygen react inside the fuel cell, that's a product of fuel cell. And then number 4 is generated electricity is same thing. Once electricity is generated, it is EV, essentially. It goes to the motor runs the car, and you get motor uses the electricity, and only byproduct for creating electricity is fuel cell stacked with water, which is emitted through the tailpipe. So you see that water.
Byproduct
Yes, to.
So the product is electricity and byproduct is this. So you feed hydrogen, and which comes from sun and wind anyway. So that's nature goes in, nature goes out, kind of that way. So no CO2, no other gases. Sometimes one of the complaints I make from my own personal experience in the morning. I don't know here whether you feel like that. So work starts at 9 o'clock. I need to drop my wife together to go beside my workplace. My wife works also beside the center. So it's probably 20 kilometer drive in the morning. So it's 8:30, 8:15 to 9 o'clock. So when I go, sometimes so much smoke, because in the morning even Melbourne City is pretty clean, but so much smoke sometimes going through, and I feel like 20th century or 21st century we live in this country, in a nice country, everything nice and clean, and this, how can I avoid that? So, but if this is system, I think that put more importance on the air quality than CO. Well, CO is important too because of the global issues. So that's why I convinced that hydrogen is a goal, right? Hopefully we agree. So that's a bus. So that top is a hydrogen cylinder kind of pressurized cylinder on a flat way, and they have got a fuel cell here. It's not big fuel cell, and that can run 17 hours without being. And it's like a bus, essentially no chains. Only the top they have got a hydrogen space, and here is a hydrogen fuel cell.
EV bus. It's an EV bus.
No, not EV.
It's an EV bus placed with
It was
hydrogen.
just like but the weight of that material compared to EV
It's
is
very
much
less.
lower.
Battery-
Even though that is
battery-
composite, even that is composite, but it's still that is light compared to 2 ton EV maybe, or if you have 2 ton batteries or something like that. I don't know how big the battery is. So that's yeah, the GM Honda has got another system that again that sort of. So this is composite material, and there's a throw many times and it still doesn't explode and things like that. So those sort of testing are done. Although there is a perception of hydrogen like a car, it sometimes explodes, but it's a social perception. Petrol has problem too.
Petrol is one
What are the hazard of storing hydrogen? Is there any hazard?
I don't think so. It's like CNG vehicle. You go in a CNG vehicle, what's the problem? So you have to manage it obviously. That risk you have to manage. So sometimes people say.
Brand selling.
So another thing, ammonia. Ammonia. Some people say that ammonia. I think handling ammonia. Maybe ammonia can go to a plant as carrying hydrogen. You take hydrogen and use it. But if you want to use ammonia in an engine, which I have put some research also, and there are a lot of activities going on, because it will be producing NOx, and NOx you can. So if you capture NOx, then it's okay. But problem with that, I think ammonia, this mass around, ammonia is a very nice material. So if something leakage happens, etc., better I will be feeling more comfortable with hydrogen. So in that sense. And what I was going to say, I lost my thought. Sorry?
Smell of ammonia is also not good.
Oh, so odor. That's right. Yeah, that's true. What I was going to say something. I think yeah, but broadly, that's another thing I was going to say. Toyota, most of the car companies, they have a huge experience with IC, right? Internal combustion engine. Now Toyota has already model where instead of like this is a fuel cell arrangement. So you've got a fuel cell producing electricity. So that is hydrogen is supplied to the combustion engine and it combust hydrogen. And there is already they have got a model.
Mitsubishi also
Have that model. So if that model is there, already they have got hundreds of IC cars. So instead of petrol or instead of gas CNG, you put hydrogen. So it's not too far to dream, I guess, isn't it? Only thing is that still the car is expensive. That should be the problem.
Injecting hydrogen is a challenge for the IC engine because the
Combustion point of view, but Toyota have solved that one. Actually, one of my colleagues is
And
close to Toyota.
another issue is the small molecular size of hydrogen.
Yes.
It can
Because, yeah.
surely pass to even a small vacancy,
Yeah.
isn't it?
So there are some issues holding up, that getting the energy out and managing and operating because hydrogen is different material. So, but if Toyota already solved that, and if you believe that, maybe they will be working on advancing further. That's another way to use hydrogen. I think that my feeling is that if that breakthroughs happen, that is more realistic. But then they have already the system available. It can be just simple system rather than you make lots of fuel cells. So I showed you this one probably in Australia. This is Korea. So Korea, they are saying POSCO, steel mill, right? I don't know what they are doing. Do you have any idea what they are doing with hydrogen in POSCO? right, maybe?
No, they proposed to completely eliminate the blast furnaces by 2047.
Yes.
So that's why they're very aggressive.
They have started from 2017. They are work.
So unless furnace is replaced, no fuel cells is like
In the steel plant, blast furnace is the main thing.
Because I believe Japan has already stopped investing in any technology supplying to blast furnace.
Is it right?
Old blast furnace.
So those countries, I don't know, they have got mandate ready. So that 2021, they are thinking by 2050, 30 million ton, 2030 less than 5 million ton of hydrogen in Korea. And they are thinking about, I think there's a
30.
number of cars. So at the moment in Korea, so that's 2023 statistics. So I believe that maybe added 2 more. So at least nearly 40,000 hydrogen cars maybe in Korea. that's going to be nearly 400,000, 300,000.
Some cities in Korea, they have prohibited ICGs.
They have stopped it.
Completely.
That's I don't know.
What Moscow is doing is they are building a pilot scale FDR. It's called Hyex.
Right. Okay. So you see that one given by car company, obviously, that other we have been to few of these facilities, I think. So with Australia, they are. So I think we feel like Korea is a very good partner for us because USA, some issues. Europe, although USA is a very strong partner for CSR for Australia, then Europe economy, not that great. What else? China, we cannot. China is very good, but economy good, but it's other strategic reasons. Now, who else left? I think India is still needs. India is good.
Ramp up.
India's future,
India needs ramp up.
but it still needs to be have afford that sort of strong market. Korea will be the best market for us in this sense because they can inject products. They have a good manufacturing system. A lot of investment in technology. A lot of good universities, R&D facilities. So that's why we see that lots of our research, lots of our trading is happening in Korea, Australia, partnerships proposing hydrogen use, battery use. So I think Korea and India will be the biggest partner. And to be honest, all these things happening, India is a kind of lucky situation to exploit that. But unless you move fast, somebody will take over. There are other countries in the Asian countries. Everyone is they have got population. So, but India has got good qualified people, good English, British system to some extent. So there are a lot of advantages. So that outcome somehow, if it is taken over by someone, that's obviously lost. That's my view. Does that kind of are you agree?
We agree.
So that's sort of really refueling station. Actually, as I said, we have our own refueling station. That's a highlight. I think they are usually going to refuel 5, 6, 7 cars a day. These are still. It doesn't cost too much. I think it's same as petrol, $1 million or $500,000 to have a petrol station or similar to hydrogen station. By the way, any refueling station in India at all? Anyone ever?
No car, no refuel.
So why the charging station for using
There is no car.
No cars, no buses.
No bus. Hydrogen is zero.
Even Bangladesh has one car. You know that one? Bangladesh has 2 cars. Actually. One refueling station.
Hydrogen train?
It's interesting because I know Bangladesh bought 2 hydrogen cars and they have got one refueling station.
Tesla is just coming.
It's going to launch this.
India is not having sufficient English.
Tesla is launching in India this month.
So look at Japan's hydrogen strategy. The basic hydrogen strategy was revised, adding new targets and highlighting the importance of international expansion. So they have got 4 goals. First, to increase the supply of hydrogen and ammonia in Japan from 2 million tons to 3 million tons by 2030, then to 12 million tons by 2040 and reaching 20 million tons by 2050. So Japan is the most aggressive, but they have a price target. They have got 20 yen per kind of unit of hydrogen, I think per kilometer, not per kilometer. If you translate that, that will be about $2 per kilometer. If somebody can deliver to Japan, Japan will switch everything off and transition to directly to hydrogen. But nobody can deliver that yet, I believe. Second, the strategy seeks to reduce hydrogen supply cost to Japan. 100 Japanese yen now per kilometer to 30 by 2030 and 20 by 2050. So 20 is the target. And 20 yen equivalent to I think $2 per kilometer. Third, the strategy seeks to expand the amount of water electrolysis equipment made by Japanese companies to approximately 15 gigawatt by 2030 on a global scale. It's a huge number. I think, I'm not sure, maybe there are companies working on, but we saw the challenges, the material issue, they need also materials. They need also the mature technology. So 15 gigawatt, actually Australia has got now 5 gigawatt, I think, or 2 gigawatt. One of them we are going to produce hydrogen technology. Finally, the strategy aims to attract public and private investments into the hydrogen and ammonia supply chain sector, setting a goal of more than 15 trillion yen or $100 billion next year. Or US dollar. 100 plus. So I feel Japanese are very, very interesting nation. They are everything they plan and they go by the plan. Doesn't matter whole world collapse, they will go by the plan. So very straightforward, very methodical and very kind of to the point, kind of black and white. So this is That's why they're developers. So no here and there. And once the plan, let's execute it. Nobody will question.
Basically.
So this is a company, our Hadian, solid oxide electrolyzer technology, I told you. So that's Hadian. So that's power consumption to generate 1 kilogram hydrogen. So normally, the solid oxide electrolyzer is a 40 range kilowatt hour. This is alkaline, this is proton exchange, this is 55 plus minus. So you have got significant reduction, but at the cost of you have to have some waste heat to have the steam generation. So that company, solid oxide electrolyzer, uses a ceramic cell to split heated steam molecules into hydrogen and oxygen. SOE operates at temperature of 800 degrees Celsius, which generates heat from industrial process to make the cell conducive or productive. Sorry, the heat reduces the electricity needed in the reaction by 30% in comparison to them, and alkaline electrolyzer reducing electricity costs. Synthesis gas can also be produced at the same process in the SOE electrolyzer. So this is our technology, our IP has been marketed by this company, and they are marketing this product.
Which is the biggest hydrogen manufacturer right now globally?
Globally, I would say ITM Power, Siemens,
ITM Power.
ITM Power, they were British company, I think. But Siemens and Nel Hydrogen, that's another one. That's more on the conventional technology. But if you look at SOE is Sunfire, a company called. But Radian is new player in the market. So it's not, there are, I think, the PEM technology in India I talked about. So there 2 years ago when they started 22%, now they're 30 employee. Similar Radian, they are improving and expanding. So it's within 2-3 years the company grows. So we have some hope and investing hope they will not be in vain. But that's what is happening.
Hydrogen capacity should be defined in a million ton. I mean, MT. Sometimes we're talking kilowatt, sometimes megawatt, sometimes MT.
What is the unit? Oh, this is
What should be the unit?
So when I say
In the
megawatt,
capacity, in the capacity.
so PEM or SOE doesn't matter. So PEM, okay? PEM electrolyzer usually sold in megawatt because the electricity need. So 1 megawatt means 1 megawatt electricity. Now 1 megawatt electrolyzer, how much hydrogen will produce? Roughly 130 tons.
We should talk in the output product, no?
So 130 tons hydrogen per year.
1000?
150, say 150. So 1 megawatt means 150. So 1 gigawatt means 150,000 tons hydrogen per year. And so that's a kind of reasonable, I would say, big plan. So now, why we say megawatt? Because the electricity is the input, right? And product is hydrogen. Sometimes people say normal cubic meter per hour or per day or per year, or tonnage is sometimes difficult because hydrogen is gas. Volumetric is a term, you know.
Meter cube is easier.
So, and then standard cubic meter, you can compress it, then the density goes up.
Because in the power unit there is a confusion now which technology they are
So,
using. If they are using SOE, requirement is different. If they are using PEM, requirement is different. Power requirement is different. So it's difficult to address how much hydrogen they are making.
Unfortunately, in the industry, that's the common norm. This is the electrical capacity. Obviously, sometimes hydrogen is another thing. Don't say that one because if you run as a 100% capacity, but sometimes you got 20% electric, 40% solar. So that's another thing. A lot of people do not. So you can electrolyze 100% run. So you invest it 100% once, but you need to make sure that it counts 20%. If it is run only, you don't have. You have 50% of it. You have a size electrolyzer run
8 hours.
8 hours, or you have a smaller which is less cost, but out. But in that electricity comes from some. So it's a balance. Costing, a lot of people who doesn't experience in this area, they optimize that one. These are capacity with your electricity source, so it all in line, with each other, optimize. Do you understand the? So
We can say that now ours it is running. So this is the component we can in that, and capacity is 150 meter cube green hydrogen and maybe 300 meter cube for the blue hydrogen or gray
you
hydrogen.
can say that one. So in that case, you are running the plant
Yeah, if you want to run the plant.
But it might be very expensive,
Okay.
very high CO2. It
Okay.
depends on because how electricity is coming. So that's why in Australia, most of our plants will be dedicated power for electrolyzer. So they in that case dedicated renewable power. So solar plant.
Solar or wind?
Large electrolyzer and 8 hours. That is good.
That's but it depends.
But
You need to put the
capex
numbers
is
in
high, na?
interesting, not-
Capex is high.
Isn't that because your capex is
Capex is high.
So it's a bit of trade-off, and lot of analysis I've seen, they don't take into account, and the customers who are buying it, they don't understand that because I'm buying an electrolyzer, I know it will be 150 ton a year, 100 ton electrolyzer, but that's not the case. That's 100% capacity basis. Do you understand this dilemma? So I think I can tell you, not really a lot of people will not tell you these things. So if you want to buy the hydrogen company into a company or anywhere, and if you see the analysis, you ask those questions. What's the capacity?
Yes. Obviously.
So that's why the question is right that whether should you specify in terms of electricity need or should you specify in terms of hydrogen production? Ultimately, you need the product.
Yes.
You should go by the product.
Our requirement is loaded, not the electricity requirement.
So is that clear now? That's good, very good for raising that one because this is the only tricky thing I find that maybe 1% in the industry people who are interested about hydrogen energy do not understand. Because they just simply look at the because most of the equipment will buy like that, isn't it? We will know that this is the capacity, we are buying this capacity. But in renewables and hydrogen, it's different quality. So if you look at the Germany, they are saying by 2032 they have got lots of pipelines, airport dedicated pipelines. And Australia, Germany, a lot of collaboration happening. Many companies you can see these are the people in Europe, a lot of active companies. They are also producing. A lot of German companies are producing electrolyzers. So that's a construction going on. So let's look at a little bit developing countries. So forget about India, later I'll come back again. But Thailand, Philippines, Laos and Brunei. So all these countries are seriously considering hydrogen energy fuel. Thailand, Philippines have built and are testing pilot plants. Both countries have got at least a couple of pilot plants each for country. Laos has excess electricity and considering hydrogen for competition. So I've done quite a bit of work development about so the university, the government, the industry will speak about that how you can bring hydrogen expertise. And in many countries, skill set that's also important because it's a new industry. You don't have you need to reskill yourself. Brunei, they have some renewable resources, not much, but they think in Borneo Island or the neighboring countries they have got excess electricity that will come from Asian grid, and they use that electricity to make hydrogen and then sell to someone else because they can invest. Someone has to have money to invest. So that if they have that money, they can be a player in that field. In India, formation of the Ministry of New Energy. Is that new ministry? Have you heard of that ministry? Ministry of New Energy.
Yeah, it's a new ministry.
So suddenly, who is the minister?
I don't know.
In India.
It's a ministry.
So the ministry is a completely full-fledged, lot of activities, lot of money, lot of
Almost 10 years old.
okay. So National Hydrogen Mission, many countries have. Goal grow demand target 5 billion ton by 2030. Do you think that are achievable and make sure supply catches up?
Prahlad Joshi.
Prahlad Joshi.
Prahlad Joshi.
So do you think this is realistic?
And demand of water, renewable energy.
So grow demand, not necessarily just 5 million ton per year hydrogen by 2030. India would like to produce maybe green, maybe blue, maybe mixed, and then make sure supply catches up. But my feeling result would be they would be thinking about green hydrogen, isn't it?
If it is hydrogen, it should be green.
And it's not far away. I'm not sure what's the status of that. Make India for electrolysis and other technology initiative. I think it's a prime time. I wish someone has got money in India.
I think there are 3 companies which are currently actively looking at it. One is Reliance, another is Tinco, and another L&T.
And what is that?
L&T.
LNT.
LNT.
Larsen & Toubro.
I see. So is that an Indian company?
Yes, it's a big giant. Construction big giant.
What I know, Reliance, a bit of movement I heard of. Adani also has an electrolyzer program probably.
Green co.
Adani is more bullish in the solar and wind. Very bullish.
And Suzlon, I know Suzlon.
Suzlon.
Suzlon is a wind energy instrument supplier.
So what's that wind man of India, Sushil Tati, isn't it?
Sushil is a Sudan.
Found that. So I think those companies who are in the battery business or in the kind of energy business, they may be thinking about it. Yeah. Transport is still industry, shipping and port readiness, manufacturing focus, but breathing is still not yet. It's a kind of for the sake of the included. But we are
But the technology is moving very fast.
yeah. So it's hard to know. Maybe. Yeah. So Indian mission, so demand creation, export market. I don't know. India is their own need. I'm not sure whether export is possible also. Probably no. Why not? Isn't it? Maybe capturing global demand because there's a countries like Japan, Korea, they use a lot of hydrogen and they don't have renewables or land, etc. So anybody can produce that. Substituting imports, particularly. By the way, do you know Indian fertilizer? You make urea, right?
Yes.
And urea is subsidized. So yes,
Urea subsidies.
heavily subsidized.
Because of farmers.
For agriculture.
And they use natural gas, right? So I think these are kind of national kind of government must be aware
National
of.
missions.
If you can make some hydrogen, give it to the urea plant so that they can reduce the dependency on the import, or maybe that way maybe another option. Domestic demand, multiple sectors, and then incentivizing. I think there are tax incentives already, is it? If you produce clean hydrogen, you will get money from government.
Maybe.
So, and also direct financial incentive for electrolyzer manufacturing by government. Green hydrogen production. There is some incentives. In Australia, it's $2 per kilogram incentive for production of clean hydrogen.
$2 per
$2 per kilogram.
kilogram.
Because industry is saying it costs maybe $5 or $4. The market is probably asking half of that. So government says, okay, we subsidize too. But my understanding when it is money, they will say that you can get that benefit as a tax or something. So it's but anyway, it's the same thing ultimately because government is someone is paying. So government is giving that incentive so that the companies can come and produce more. And resources, finance, renewable energy, banking, and storage, transmission. R&D, as I know that NCL colleagues, Dr. Lele and others, Gopinath, one of the colleagues I know, he's the man in here. Our contact with a lot of also Australia, India collaboration under this scheme. And ease of doing business and infrastructure and supply chain, ports, equally, hydrogen hubs and pipeline. In Australia, we've done a lot like that. South, north, east, west. I think India should also look at because each hub has got another strength because you are bringing the regional strength. That some parts of the region may be more wind than others. Some parts of the region may be more solar than others. So that has to be matched accordingly. And this is another important area. Because some countries will find that we have everything, but there is no standard rules and regulations. Because without that, it's like gas industry. So you need to have a very strong regulation, isn't it? Training, safety. So these are important, quality control that side. And this is another thing. I'm not sure. I know that some IITs are moving to this space, curriculums, safety, functional development training, things like that. So, but in Australia, as I said, many universities have got unique. They are chemical engineering, they are energy engineering. They are moving to academics, developing curriculum and training in hydrogen area. And many of the academics, as I said, 200 maybe to at least 3,000 researchers. In CSRI, last time I knew at least 300, 400 dedicated researchers working in this area. So I think they call it S plus 3 concept. Safety energy must be supplied safely and steadily. Energy security maximize the use of indigenous energies and prepare energy for infrastructure. Economic efficiency provide modern convenient energies at minimum and affordable cost. Environment secure, sound and manageable conditions and lower the zero emission to a lower possible level. So that's not only India, it's applicable for every country. Now let's do some calculations. Okay? How much fuel is required for 1 megawatt electrolyzer? Okay? So, or how much input essentially? So 55 kilowatt hour electricity input for producing 1 kilogram hydrogen fuel. Water electrolysis technology is 11. So 1 kilogram hydrogen means 11 normal cubic meter at ST. Okay? Now, say if we want to make that hydrogen and I want to get power back, so 1 kilogram hydrogen has 120 megajoule lower heating thermolysis, 33 kilowatt hour of energy. It's contained energy. Okay. Now fuel cell efficiency is generally 55%. So if I put that hydrogen in a fuel cell, the net electrical output will be 80 kilowatt hour. Are you with me? Okay. So you multiply that by that. Everyone in the back, okay? You understand? Now hydrogen fuel required for 1 megawatt hour electricity output will be 54 kilogram hydrogen, or if you multiply by $2 per kilogram, it will be $110 per megawatt hour just for fuel. And for thing is that no CO2. So if you put CO2 credit, say that a country suddenly put tax in India, apparently is that this bill passed? Tax bill, carbon tax. Some discussion going on. So if you see that carbon tax, they even minimum they impose say $50 per ton. I don't know what will be the number. So $50 per ton means that you in a power plant situation that $50 you can reduce from here. It's a kind of how we compensate. Does it make sense? So you deduct $50 from here, your then becomes $60-70 or something, I don't know whatever number. Make sense? So far you are with me? So now with the car, so if you put that kilogram hydrogen in a car, 110 kilogram total kilogram, so market price. So 1 kilogram hydrogen will take you 110 kilogram, 10 kilometers. Sorry, 10 kilometers. So now market price in US already they have got hydrogen power station, fuel stations in California. They sell around $16 per kilogram, but that went up to 35. Now, so it's a kind of volatile market.
$16.
So, but on an average, say $16. In Australia, if I want to sell someone, they will be marked like that because $2 you produce, it has to be all these retail, etc. It's like a price to to the user. So to the user price say that. So then $1.5 per petrol. I don't know in India how much petrol?
In dollar 1.2. In US dollar 1.2.
1.0 US. So I'm saying 1.5 Australian dollar. Similar.
No, Australian dollar is I think.
No, it is weaker than US dollar.
Yeah.
So 1.2.
It's a 1.8.
So could be 1.8. Sometimes you pay actually because of the old. Nowadays I pay nearly $2 per liter.
1.8, 1.9 is right now.
Yeah. So 15 liter petrol is required for 100. It is. I mean, in my car. I think I calculated. So that's.
Poor mileage.
So that's like a 24.
Poor mileage.
Yeah. So that 48% of the fuel cost, but petrol car is 34% cheaper with high CO2. So that's the kind of scenario.
If the cost of hydrogen is minimized, then
There's
So-
only.
So same can.
it is from renewables, then the cost will be lower.
It will be maybe, but around cost. I don't think it will be more lower than that. Maybe if it's a $10 per kilogram, ideal scenario. So if you have say $70, equal more or less. But on the other hand, a car is expensive. I think car. So, but that's, I mean, when electric car came, it was expensive, isn't it?
Yes.
By the way, what is the
30%.
what is BYD car here cost?
BYD card is not available.
BYD car, Tesla, how much is Tesla?
Tesla is not here.
Tesla is not announced.
So what is the most popular EV here?
Tata Punch.
Tata EV.
Tata is a very small item.
Cheapest car you can buy Tata is like 10 to 12 lakhs.
So let's small car.
So dollar is how much would be the dollar?
$50 से 50 रुपए कर दो ना
2000.
Very cheap. How do they make that?
20,000.
Car or something else?
$20,000.
20.
20,000.
20,000
$20,000 Australian dollar.
The
20,000.
range is issue.
Small car.
small car
20,000 seems.
It's a small.
small car
What about Australia?
what about Australia
Australia say because we used to take a lot of Tesla. Tesla is expensive. So
How
now
much?
Tesla you can get 55.
55,000.
$55,000
60,000 Australian. Now BYD came. You know BYD Chinese company. They are probably around the same mark, maybe a little bit cheaper. And now Tesla didn't go down, whereas BYD going down. And now equal sales. Yeah. Previously Tesla was the number one. Now I think at the moment 10% of the total car sales in Australia is EV car. And they are maybe divided, you can say 60% BYD, or Chinese car there's another MG, another couple of brands I think they're
MG.
cheaper also.
MG.
Cheaper.
More than
But
that.
Tesla Tesla doesn't
No.
work because of the
Generally,
price. But some people buy Tesla because of show off and
Brand value.
brand value.
Sorry? My car is petrol car. It's a Toyota Cougar. Toyota Cougar petrol car, which is SUV. So that is probably to get 60,000, 55,000, 55,000.
SUV 55,000
Yeah, SUV $55,000.
डॉलर 50 से मल्टीप्लाई कर दो 1 करोड़.
So but that's a very good car. I got new Toyota Cougar, but before I had Toyota Corolla or the Toyota Camry, which is most popular car in Australia and particularly immigrants. Relatively cheap, very nice car I like, but my son used to force me to buy that Cougar. Yeah, so it's a mixed market in Australia. So if I go now, my son might need to buy a car. We'll go for EV. Because we have got solar and home, that will be very nicely work with EV. Because if you talk about the cost for a petrol car, I really decided to buy 5,000 for fuel per year, $5,000 plus maintenance, etc. It will be probably, if you have a car, whether you drive it or not,
You have to maintain it.
3,000-4,000 you have to pay for insurance, road tax, etc. So maybe 4,000. So roughly $10,000 you budget for a car cost. If you have EV, that 5,000 fuel element will drop down to probably 1,500. So that's number very low, and also the maintenance goes down. So you don't need to service as nozzle, etc. So it's probably, I think EV car compared to petrol car will save you at least, I would say, what is that, 25%, 75% reduction.
75%.
So that's good thing, but I'm not sure about hydrogen car, how much, it doesn't need maintenance also, because it's a fuel cell, not moving part. It's like same as EV type situation. So is that comparison, it makes sense?
Yes.
So I don't know, if still people is not taking hydrogen, maybe they transport people, you make a car and
The cost is a factor, na? New car is a
is
very
expensive and
costly.
why would it?
Yeah.
So I think these companies are now the Hyundai Nexo, Toyota Mirai was the first. Mirai means user or something like that.
65 lakhs.
Until unless hydrogen car running cost is less, na?
Less,
No,
yeah.
no one will buy. In this case, running cost is
Running
also
cost is
high.
high, car cost is high,
Yeah.
and there is no petrol station, no hydrogen station. No fuel station.
Even if the hydrogen station is there, if the running cost is high,
People will
then
not
buyer will be less.
So now, only thing is that say if they put carbon price on the electricity,
Yes.
then maybe that's a,
Then there is a
that's a carbon trading maybe sounds like good business. So now
Investment 2.4
Say-
billion.
with hydrogen, prospect of hydrogen fuel using wind example, okay, let's look at that. So wind potential for that offshore, say 20 gigawatt wind, some Japanese estimate for it, okay, let's you say 0.4 factor, okay. So that means 0.4 times 2, 20 becomes 8 gigawatt net capacity. So it's like equivalent to 4-5 power station. Make sense? Even say small amount we take, so it will be 1.2 million ton hydrogen. And this is small country, I'm not naming the country, but small country have that potential. So you can have 1.2 million ton hydrogen, 39,000 gigawatt energy required, or so that fuel cell technology at a steady, so you can get 2.7 gigawatt net electrical output. Investment we estimated, we can do that one. So roughly say 2.4 billion, and you get revenue, that's our revenue, you will get at $2 per kilogram production. So it's a kind of big wind. If someone has offshore wind, this is kind of we are thinking about whatever investment. So it may be depending on few years you can get your money back. Oxygen more than 5 times as byproduct, medical oxygen, in the like we all use still. By the way, what's the oxygen price? Still any idea? Indicate it. You don't have to give that exact. So $200 per ton or less. So what you may have production your own. That's one thing. And if somebody deliver, that will be cost like. If somebody produce outside the plant and deliver to you, that will be cost like. Maybe your cost you produce maybe 150, maybe 100 because you produce your own. So that plus that, so $3 billion, 3 plus $3.6 billion is the revenue from this solar system. And output electric power is cheap, low value product for hydrogen. That's my view. Think to produce hydrogen from power, just power. some nuclear facilities many countries have got, you cannot dump electric load, and sometimes there is no use of electricity at certain part of the day. You use that one to buffer or to manage that reactor so that you can make hydrogen. And these are the technical area. Better to transport fuel cell is a transport fuel for cars, buses, trucks, when super automated vehicles technologies are available. Agree?
You are saying the oxygen based and oxygen, we sell oxygen 1.2 billion will get.
If you have that use that nearby, so if I need hydrogen, say if somewhere there is no use, then that's not visible. But say if you have a steel plant nearby, there is a big hydrogen park, potentially that can be just right plant. Simple. Okay, agree? So that's our hydrogen technology demonstration facility. There is a unit called lab home. This is a like your home system. So this unit has, so this you see that red kind of boat-like structure. Those are metal hydride, they call it hydrogen storage. So they can spawn, they like sponge. They will capture hydrogen and stay there. If you change the temperature, they will release it. Okay?
Capture from here.
So here there is an electrolyzer. So it's a plug and play. You plug with a water source. There is an electrolyzer. It will make and plug with power source obviously. Power and electric source. That's it. That's an Australian technology kind of. So they will make hydrogen. There is a fuel cell. They will put through the fuel cell. There is also a I think water treatment plant. Obviously water small water minor treatment. So the hydrogen is produced and stored here. Okay, and there is a battery. So if it is a renewable power, you can have in the battery. You can have when battery is completely full, then you can produce hydrogen. Goes to the tank, both one tank here stored, and then there's a fuel cell. So when there is no solar or wind, then your battery kicks in. Once battery is just completely, still you need power, those will release power, hydrogen, and that will go to the fuel cell, and that will give you the power. That cycle goes on and off so that you don't depend on the grid at all. Does that make sense? So this is kind of a home unit, a typical home in Australia. And it will cost probably say, I think they have different products, I don't know that, but yeah, 35,000 marks. 35,000, $5,000.
For how much kilowatt capacity?
So that's for a typical home.
5 kilowatt.
It's
How much?
actually more, probably 7 kilowatt maybe something.
7.
Maybe 10 kilowatt, I cannot remember that.
And kilowatt $35,000.
Because in our Australian homestead, lot of energy, our per capita electricity is 10 kilowatt hour per day, something like that. So that's so we say that when you build a house, you take this unit, you don't have to pay electricity at all.
Electricity is very zero. $35,000
Something
for
like that.
extra cost.
Extra cost. Yeah.
$1,000 is a very big money.
Well, if you say usually they do like bank loan, so sometimes 700,000 plus 35, you pay slowly, they don't bother.
Interest is
Because in Australia nobody buys home from pocket, nobody can. You have to go for a mortgage system.
every place.
Here also.
No one can buy from government.
So that makes sense that way.
That was some of money.
But problem is that obviously that is to reduce CO2 emission, etc. If you say average life cycle carbon is a critical hydrogen production, so these ones are renewables, okay? And this one is the SMR. So that's so from coal or gas, 12 kilograms CO2 per kilogram hydrogen. Renewable is less than 1, and India is saying 2 is the certified. This will be certified hydrogen. Under the certification scheme, this will be clean. Make sense? Everything? So far, have I spoken anything unclear? Any question or confusion? What else I want to do something with this? I want to do something. Seems like finished. So, electrolyzer status for renewable hydrogen production, as I said again, I think it's the same information. So that's the equipment cost. Okay. Purity, operational maintenance, technology stage, laboratory, but this is a bit old information. I would say trend is commercial. Solid oxide even not only development, it will be pilot, so it will move towards it. And electricity consumption, this one remember, we used to be that kilowatt hour per kilogram. 1 kilowatt hour per near cubic meter. And you need to multiply by 10, 11.1 to get conversion from cubic meter to kilogram. So that becomes 55, that becomes 30, 50, something like that. Okay? So that's your
hydrogen is 0.9, not
so 1 kilogram of hydrogen, 11.1.
0.09.
So obviously lifetime is also same thing I'm saying. So currently there is no definitive calculation available for the expense of producing clean hydrogen. Quantifying the cost of hydrogen in real world scenario is a difficult task, and making broad comparison can lead to incorrect conclusions. You are thinking about it by now. Hydrogen production cost exhibit significant variation based on geographical location, country, financial conditions, and energy access. Predicted levelized cost of hydrogen is $1 per kilogram for conventional hydrogen, $2 per kilogram for low carbon hydrogen, and $3 for renewable hydrogen in the most advantageous production areas. Cost of renewable hydrogen can vary significantly from 3 to 50, particularly based on local conditions, and may be higher. These are the kind of contributions. Makes sense, right? You agree with me?
Yes.
And obviously there are some, any project has got risk assessment in cycle. I think all these still colleagues, you are familiar with this sort of framework, right? Project, so that we are able to have initially some understanding about the cost and risk, and slowly you have a commercial operation, but it's that the death penalty policy, taking over that, convincing, getting the finance, in kind of capitalistic world, that's how it works, and it's not necessarily everything is free. But on the other hand, we know the benefit is there.
Can you explain that?
So, sorry, this one is kind of, is initially, how long does it take from thinking concept to a project, and what are the risks, initially you need to have feasibility, feasibility, then you need to have, the large development activity, and final construction, and you need to seek the finance, and you need to recover, recreate that, and those sort of small things and activities. I'm not a project manager, but I understand that project management, engineering, construction, procurement, that's the cycle, and if it is a new technology, that's more risks, more, evaluation and assessment required compared to the established system.
We call it death valley, the middle part.
Yeah, kind of, isn't it? That sometimes it doesn't stack up, then you get out and you lost money, one other week. So big companies can take that risk maybe. They one week maybe lost, another week.
What is COD?
Isn't that? So feed, I think front end engineering design, FID, COD, commercial, I don't know what's that called. Yeah, I don't know, there is something commissioning, no, I don't know what it's called. So anyway, so that's another interesting thing. This is all our own work, so I can share. Motivation for national support for green hydrogen in selected countries. So we analyze these countries and reduce emission, you diversify energy supply, you foster economic growth, you support technology development, you integrate renewables, develop hydrogen for export. So you see Australia, most of them are tick and very good situation in Australia, particularly export. That's our you analyze. I don't know India is there or not?
No.
Yeah.
14.
So India seems like reduce emission. There are 3 ticks.
What is the meaning of ticks? How many ticks are what it means?
So more ticks means more better, actually.
But
So
Australia
but ticks is not just like a mock ticks. It's some evaluation behind their socio-economic condition, government agenda, energy security, energy availability, etc. So I don't know if I think obviously Australia is good situation, more export oriented.
But
it's like Spain, other countries,
very
Russia is
emission
export
It
oriented.
is prepared by you.
Sorry?
Prepared this.
Prepared by us, but behind lots of other, calculation and intelligence, etc. we feed in, and that kind of, because it's easy to convey the message, if we put the numbers and index, etc., you will probably get lost. Do you understand what I'm saying?
The country is behind in reducing emission.
Sorry?
Australia is behind in reducing emission cycle.
Australia is already reducing. Reducing emission is because we are already
No, it's
our
national support for green hydrogen. This is
So you should prepare a readiness index for each country.
It's not actually government support.
What
Assigning-
about readiness? Readiness index. Yeah, kind
You
of.
can assign a weightage to every one of the
Yeah,
parameters.
because the problem is that if I move in one index, then that lost, or because each
No, you can assign a certain weightage to each index. Then you can come up with a weighted average.
one weighted average, but when we present to the people then say only one index is not good way to convey. You need to have with the multiple things. Anyway, that's one way to say that one. Yeah. So, but one of the thing I guess, what is I going to say here? Yeah, but anyway, so that's you can make lots of assumptions here, lots of conclusions, but this is one of the way to say this is the situation for a country. That's another one, classification of countries based on energy access. That's also one of the colleague works. So you know, type 1, type 2, type 3, type 4, type 5, and type 6 we categorize. And energy by energy type, example country and why they are. So if you say India is type 3 country maybe, so whereas Australia is type 1 country, so they're self-sufficient by fossil fuel and renewable energy. So we switch our all energy source to fossil, we can. If we go for wind, we can. If we go for solar, we can, because we have the luxury. India fossil fuel efficient and significant solar and moderate hydro and wind energy combinedly self-sufficient. So that's why if you look at energy type, you may have some moderate hydro, moderate wind, solar significant, China, India, countries like that. That's how what technology will be suitable, and that sort of evaluation people need to do.
India is also type 3.
From this sort of definition or scheme of things, that we think India will be type 3 according to our definition. Okay?
So India is currently sufficient without any nuclear.
But you have so much people, the demand is high, going up in a trend, developing world. So those are consequences. Whereas Australia, they are more or less saturated. Our population is low. Our industrial emission also, industrial need of electricity is less because lot of manufacturing is shifting for us. And also we have lot of energy because we are net energy exporter. So I think our 70% energy is exported. 5% we only use.
India is also an energy exporter.
Net.
No.
Not net.
No, electricity, for the electricity it's
So
exporter.
net import.
Net.
It's still not net. Net means what
Net, electricity is
final,
exporter.
yeah.
Net is importer.
It's a net importer. So Australia is net exporter. So challenges for hydrogen transmission supply network. So it's a procurement which includes tax, steel pipes, tanks when they are exposed to hydrogen. When hydrogen is introduced in steel, majority steels are experiencing a loss in their capacity because hydrogen penetrates through the steel. It eats up and it leaks. So it's a small molecule, it can go through, and also in brittle steel. So these are the challenges. So that's why you need to have other specialized pipeline and pressure pipeline, pressure vessel, etc. Blend of hydrogen natural gas with a ratio up to 20% hydrogen and 80% natural gas can be used without causing significant damage to the pipelines. However, no field data is available to support this statement. So it says, literature says that one, there are some trials going on in various parts of the world, particularly UK. And also in US, maybe some trials. In Australia, we are doing it, but we are limiting only 5%, not more than 5%. 5% blending and we test it out. So overcoming hydrogen-induced temperature is a difficult task in the complexity of accurately determining the distribution of hydrogen materials and at a high detail. As the hydrogen diffuses rapidly, it has a very low interaction cross-section with electron beams, and it is difficult to accurately map the hydrogen distribution. So it's not easy task, essentially, particularly with blending.
What's the cost for this? Why hydrogen is generated in this?
Temperature means it's a low, it's a very reactive gas also. It's quite reactive. Yeah. That's why there are still guys probably going to like it. So in the value chain, that could be another option. Biomass. I think we showed that there are so many organizations, everyone their own kind of version. But ultimately, I don't see too much differences between that. But as you said, each country has their own kind of version. Scenario is National Renewable Energy Laboratory in the US. They are the most authentic. I think they are working in hydrogen long time. Rocket fuel, lots of hydrogen technology developed in NREL and lots of still good technology. They have many scientists, some of the colleagues. So I think we are for the end of this talk because hydrogen will play with the diminishing fossil fuel. So one of the things is that what we highlight that okay, forget about decarbonization, forget about everything, but the gas and oil will not last forever. Already they said oil.
We need to shift.
There is no choice. Hydrogen offers two alternatives to fossil fuels and intermittent renewable energy. Cost of hydrogen due to high price of electricity and production technology is not conducive for developing nations yet.
Yes.
So the India to consider whether it is developed nation. However, with the maturity of technology and cheap energy, will enable hydrogen energy to be true alternative and replacement of fossil fuel potentially. Start preparing skilled human resources to deal with hydrogen energy and associated infrastructure. I think that's what it for me. So is that, do you agree with that? Any debate or challenge you can throw to me that I can take, and then okay, we have to work more on.
I think we should have a fantastic ridiculous idea. Say we are starting to handle CO2 in the atmosphere, global warming. What if this CO2 is replaced by hydrogen in the next 2 decades or 3 decades? Everywhere you have hydrogen.
Yes.
So maybe the whole world will get flooded.
Started with the water. Water is not that much. We look at
Hydrogen
that.
is not freely available now. It's a
Same
process
thing,
by which we give
yeah,
it
the
that.
tailpipe will release water and roads are flooded. If you look at the ratio, only 10 liter, and nowadays when people are thinking about maybe capturing that water and putting back so that you don't have water loss at all. So that's a perception. A lot of people, if you look at the pie chart, water is very, very thin part. So water is not a big issue, but it depends on the social, if there is a big use and etc. And countries like Australia, we have got sea around Australia. We don't really.
So, cost difference is, what is the cost difference when we make the hydrogen from saline water or normal river water?
Cost difference a little bit. So saline water costs a little more.
How much more? 5%, 10% what?
So total, even if you say very expensive water, it won't be more than 5% of the cost or almost.
I mean, high saline water is a 5% only.
Roughly, yeah, that's right. If it is good water, it may be 0.5%, it may be 1%. So in between 1 to 5%, so a scheme of 100%, you are telling who bothers that kind of.
For a country like India, what I get from the presentation is that we need to invest heavily on first renewable source of energy.
Renewables.
Then only
Energy
we can,
first, electricity.
then only we can, for electricity obviously, then we will go for electrolyzer.
But do you think India has a lot electrical energy in terms of renewable moving fast?
Renewable moving fast.
It is moving fast.
Yeah.
So the solar part
So
is very
that's-
fast.
Solar and wind both are moving
So
fast.
if both are moving fast, then that what you are saying, that's already happening, right?
Like it will, the Indian target is 2045. I think,
Terawatt
like 40 to 50% energy from the renewable,
by 2045.
2045.
So and that's the huge amount you are saying.
Yeah, 40 to
So
50%.
but when you target say 10 to 45, because the renewable is like that, it read how you manage that, then without some sort of storage,
Yes,
hydrogen,
the
etc.
hydrogen is in picture for
Picture.
that only. And
Yeah.
initially the hydrogen is the carrier of the energy only. Now we are hearing that steel production is also done
Part of
through
it.
hydrogen. But initially we had the hydrogen for the carrier of energy source only.
So now my question is that in the hydrogen landscape in India, what I have presented, because I'm not in India, I don't, because if you live in a country, you get used to your sea news, etc. So according to you, what is the biggest barrier? Obviously electricity barrier. What else the barrier, 2-3 barrier if you talk about hydrogen penetration in Indian economy? What are that?
Cost of
One is R&D.
cost production, cost of production.
Cost of production will be down.
Technology. One is R&D, the research and
So
development.
if you say you are Prime Minister, what do you do?
First I invest in R&D.
Increase the budget.
Invest in R&D.
Anyway,
Because if we do not have indigenous understanding of what is happening all over the world,
So that's my last line. Start preparing skill.
Then I will add one.
Yes.
When we approach any industry, I stay also there, yes, person there. They generate like, sir, I have some specific proposal. Ministry of Steel enforced us to do the project on this green steel or decarbonization with industry partner. Minimum 15% contribution from the industry is required. The first question which we face, like, is it possible in our existing system?
This is
Ask
the
Answer the
question.
question.
The infrastructure is
number one. Number two is like, we cannot change our system. You do anything in our existing system. So, and I have this like 10% potentiality replacement potentiality is 10% only in existing blast furnace system. If your mindset is like me, I will produce the steel blast furnace and you will tell me I have to go for it, and how can we go? Then they are, it is the case of GSP. Similar case in ice class.
Then no one can start the blast furnace in the night, na?
Last CEO was, hey, after recording,